Welcome to lesson 2 on glaciation, and today we're going to be finding about the formation, flow and retreat of glaciers. This lesson is probably about 35 minutes long and will include watching some video clips. Now, to do this, you need to have open the PowerPoint as well as this YouTube presentation, because the PowerPoint will have the links to the films that I'd like you to watch today. You may remember from last lesson we were thinking about ice on the planet. This is what it looks like today. These are glaciers and ice sheets in today's world. But remember, 20,000 years ago, there was much more ice on the planet, and parts of Europe and Britain were covered in ice. So let's remind ourselves of some key terms from last lesson. These are good words to use when it comes to glaciation. A glacial, a period of ice growing on the planet. An interglacial, in a warmer world when ice melts and retreats. An ice sheet, a large body of ice. Do you remember Europe and Britain were covered by an ice sheet up to a mile thick? And lastly, what we're going to be thinking about today, a glacier, a finger or river of ice, usually extending downhill. Well, we're going to be thinking about glaciers today. Today's lesson should take about 35 minutes, and through YouTube clips and some photos, we're going to be thinking about moving glaciers. If you click anywhere on the slide, you'll be transferred to a YouTube clip that will show you a time lapse of how glaciers move. You can hardly see them in reality. The speed at which they move is centimeters per day. But this time lapse shows you how they move speeded up. Have a look. See what you think about moving glaciers. If you had a look at the clip, it looks impressive. A flowing body of ice. There are glaciers all around the world currently today. Here's one in another one in Tanzania. A very small glacier, but nevertheless a finger or a river of ice. This is in Austria. And another glacier, the fastest moving glacier in the world, this one. New Zealand, the Franz Josef Glacier. And the Athabasca Glacier in Canada, a moving river of ice. I visited this glacier in Norway one summer a few years back, and was so tempted by the colour of the blue, clear water at the bottom of the glacier, I couldn't help but go for a swim. My word, it was freezing. And of course it was. This glacier was melting on the sunny day, and all the ice was beginning to trickle into that pond you see in the foreground. So, this brings us to our main activity. I would like you to watch the information clip on this slide and answer carefully the 7 questions about how glaciers form, flow, and retreat. I would allow 15 minutes for this activity, and I would ask you to pause this presentation to allow you to answer these questions. How did you get on with those questions? I loved the image underneath the glacier of the trundle wheel measuring the speed of the glacier, and of course in summer, glaciers move so much quicker, don't they? And you should have talked about the meltwater underneath the glacier lubricating that finger and river of ice as it gradually moves downhill. Here's some technical words, boys, I want you to use in the next activity, which should take about 10 minutes. You see, this is a glacier in cross section. Notice at the top of the mountain, the inputs, the accumulation. This is snow building up at the top of the mountain, layer upon layer, accumulating and building the glacier. Now that glacier moves downhill under gravity into the zone of ablation. Ablation means melting. And towards the bottom of the glacier, the snout, there is meltwater pouring out at the front of the glacier as ablation occurs. And there is a balance, the glacial budget, between the input, the accumulation at the top of the mountain, and the output, the ablation at the bottom of the mountain. And when these are in balance, the glacier, although moves, stays in position. It doesn't advance or retreat. What a strange idea. The glacier is always moving, but its position on the mountainside, where it begins and ends, stays the same. Now, I wonder if you could have a go at that extra challenge. What might cause the glacier to get bigger or smaller? That's for those that would like an extra challenge. So the final task for today's lesson, which should take, again, about 15 minutes, is I would like you to draw a series of 4 pictures, sketches, that show how does a glacier grow over time? What causes a glacier to move downhill? What might cause a glacier to grow larger over time? And what finally might cause a glacier to retreat over time? Could you try and use some of the technical words from today's lesson? Ablation, accumulation. And each sketch needs to have at least 3 labels that are full sentences, please, not just one words, that maybe help explain those questions on the screen. I would love to see some of these, but hopefully it's all going in your exercise book. And at some point when we're all back in school, we'll be able to talk together about how glaciers move, retreat, and flow over time. Thank you for listening. I shall see you on lesson 3.